Lesson 8 in Module 4 is on percent error problems. Basically, there's going to be some error when you deal with like real life measurements, or I mean, that gets a lot into statistics when you're doing like voting things and taking surveys and things like that. There's going to be what's called a percent error on things, plus or minus so many percent. Like this is what we think it is, but we got to give us some leeway on either side. So, but again, we're going to focus today a lot on measurements, okay? Human error comes into play. So how do we deal with that? So we have something called we're dealing with percent error here, percent error problems, but we have something called absolute error. Now we've done with things like absolute value. We've heard the word absolute before, right? Absolute, final. In math, remember absolute value is like the distance away from something, and it's going to be kind of like that. We're going to take whatever our approximate value is and subtract our exact value. So this A right here is going to be our approximate value. And this X right here is going to be our exact value. But since we're taking the absolute, and we're not going to be worried about this if this is positive or negative, we're going to put the absolute value signs around it. Okay, so again, if we measure too short, we're not going to say, oh, we're off by a negative something. Nope, we're only worried about distance. Okay, so we're going to start with absolute error, and then we're going to go into our percent error. So let's practice this. How far off are we? Okay, it says find the absolute error for the following problems, and then we're going to explain what that means. Now, I do need to give you a little bit more information here because we're talking about students measuring a monitor. Okay, and the monitor, like a computer monitor, right, is exactly 15 inches. Okay, so we know what it is exactly. So manufacturer said it's 15. We're practicing measuring, so here's what the students came up with. So it says Taylor's measurement number 1. We want to find her, or his, I guess, absolute error. So Taylor measurement 1 is 15 2/8. So what we want to do is we're going to take the approximate value, what Taylor did. I'm going to write this right here so I can scroll up. And we're going to subtract the exact value, which the company tells us is 15 inches. So I'm going to say the absolute value of 15 2/8 minus our exact value of 15. And I put those absolute value signs around it. Remember, that means it's always positive. So when I subtract, I get the absolute value of, well, 15 2/8 minus 15 is just 2/8. And, well, the absolute value of 2/8, meaning how far away from 0 is 2/8, is just 2/8. And I can reduce it, right? I could divide top and bottom by 2. I'm writing out all the steps here, but I know we could have like figured this part out before and get 1/4. Now, if I wanted to write that as a decimal, because maybe, our absolute error being 1/4, it might be easier if I go 1 divided by 4 and get 0.25. All right, so different forms here. So if we want to explain what it means in the context of this problem, we could say that Taylor's, and I'm just going to be M1, measurement 1, was 0.25 of an inch away from the exact value. That's how far off she was, or he was, right? Sorry, that's his value there. 1/4 of an inch off, okay? So let's try Connor's measurement here. Again, we're going to take approximate minus exact and then take the absolute value of that. So Connor's measurement 1 is right here, 15 4/8. So the absolute value of 15 4/8 minus our exact value, which again is 15. Well, we get the absolute value of 15 4/8 minus 15, which is just 4/8. And how far away from 0 is 4/8? Well, it's just 4/8. We could divide top and bottom by 4 to reduce it. We get a half. or we could write that as 0.5, right? 1 divided by 2. In the context of the problem, we would say that Connor's first measurement, so M1, was ½ inch away from the exact value. Okay? All right, let's just do one more real quick. Again, we're going to do approximate. This is absolute error. We're going to get to absolute percent error in a second. And we're talking now about Jordan's measurement 2. So Jordan's measurement 2 is right here, 14 6/8. And we're going to subtract the exact of 15. So now here's why absolute value comes into play. If we're taking the absolute value, if I were to subtract these two things, notice we're like 2/8 away from 15. So this is actually a negative 2/8. But we're not interested in if it's too small or too big, the measurement. So that's why we take the absolute value of it. So that is really the absolute value of 2/8. How far away from 0 is 2/8? It's 2/8. Or, as we did before, 1/4 or 0.25. I'm not going to write it in explain because I think you guys get it, right? Jordan was 25 hundredths, 0.25, 1/4 of a way off of the exact. Okay, so we're not concerned if we're too small or too big, if it's going to be negative. We're just worried, how far off are you? That's our absolute error. So now what we want to do is we want to take our absolute error and turn it into a percent error. So we're going to add on to this. Oops, did not mean to do that. Okay, so let me show you what I mean. All right. This is the percent. Which is the focus of this lesson, percent error. Okay, so our percent error, we're going to take the absolute error, the approximate value minus the exact value, and then we're going to divide it by the absolute value of the exact. Okay, and then we're going to multiply it by 100%. Now, what does this all mean? Okay, so again, this is approximate, right? So that's our approximate value. Our x, that's our exact. And we're taking the absolute value of those. Okay? Now, this times by 100 here, all that means is we're going to move the decimal point two places right. We're basically changing it into a percent. Okay? So we're going to take what we just did, but then we're going to divide it by the absolute value of the exact. We're just going to divide it by the exact and then change it into a percent. Okay? So here's what we mean. We want to find the percent error, not absolute error, percent error, for Taylor's measurement 1. Okay? So remember, if we went Taylor's measurement 1, excuse me, that's what we did here. So let's copy that down. So we're going to take the absolute value of her approximation, 15 2/8, subtract the exact, remember the monitor is 15, but then we're going to divide it by the absolute value of the exact, this one here, okay? I'm not going to write the times 100, I'm going to show you what I'm going to do. Okay, so remember, we got, when we subtracted this and took the absolute value, we basically get 2/8 divided by 15, right? There are nice long lines here around that. Well, we did 2/8, 2 divided by 8 is 1/4, or I'm sorry, reduce it's 1/4 or 0.25. So if you just take a calculator, okay, and I can grab my calculator here, and if I go 0.25 divided by 15, I get 0.01666666, right? Okay. That is like, we'll say the percent decimal, right? No, I'm sorry, like the decimal error. We want the percent error. So what we do is we take our decimal point and we move it 2 places to the right. Basically, you're multiplying by 100%, right? We're making it to a percent. And you would get 1.6 repeating percent. Or you could say it's, 6 repeating is 1 2/3. You could say approximately equal to 1.7, okay? But what does this mean in this context? It means that Taylor's measurement 1 is about 1 6 repeating percent off the exact. Okay, measurement. Spelled correctly. Okay? All right, so we're just taking it to the next step, okay? So if we try real quick, what was it for Connor's measurement 1? What does this mean? Well, remember Connor's measurement 1 was 15 4/8. So we're going to take 15 4/8 minus our exact. So this is what we were doing on the last page of notes. But now we're going to divide it by the exact. Okay? So we get 4/8 over the absolute value of 15, which is 15, which 4 divided by 8 is 0.5 divided by 15. And if you take that in a calculator, you get 0.3333. So making it into a percent, that's 33. Nope. I apologize. This is not right. And this is what happens when you're trying to rush, right? If I were to go 0.5 divided by 15, I get 0.03. So this is 0.0333 repeating. So if I move it over 2 places, I get 3.3 repeating percent. Or 3 repeating is 3 1/3. And it's okay if you don't recognize that. Okay? So in this case, Connor is 3 1/3% off the exact. Okay? So what is the purpose? Well, I'm going to type that. It tells you how big the error is compared to the true value, the exact value. Okay? So it just tells us, and we're 3% off. Okay? It tells us how far off we are from what it exactly is.